Thanks for having me here tonight. Thank you for inviting me. It was a very interesting session about how to improve the quality of your JavaScript skills. That's a topic very close to my heart because we see a lot of JavaScript developers coming in at the level of copy-pasting jQuery snippets. And
those are
jQuery
developers.
Yeah. Yeah, maybe we should call them JavaScript developers, yeah. So it's definitely an area that we also hold very close, and we really want to encourage developers to bring their JavaScript skills to a new level. So thank you also, Philos, you guys for investing in that as well. A little something about me. I'm a developer evangelist for Appcelerator, so I'm not objective. I do claim to tell you the truth, so let's see what we can make of it. Follow me on Twitter. I will tweet links to the slides early morning when I wake up. I have 2 young kids, so it could be like 6:30. We'll see. We're going to talk about a whole suite of different brand names here. I'm going to talk a little bit about Appcelerator, what we do, because tonight we're going to talk about apps, but we do a lot more. So I'm going to keep that short, but just give you a little bit big picture. I'm also going to talk about JavaScript to native as a concept. There are more players out there now that finally discovered that JavaScript can be good for more than just building web frontends. Even Facebook, after their terrible nightmare with HTML apps, they finally discovered that they could use JavaScript, just don't be HTML. So we're very glad for them to join the party. Then I want to go through the principles and the architecture of Titanium. I'm not going to show you how to build an app from zero to app. As long as you get the principles and the idea, our aim is for the API to be very predictable, to have predictable properties and names so that you can easily use them and build your apps. Then we have Alloy, which is our MVC on top of Titanium. So I'll explain how that will make it even easier. And finally, if we have some time left, I'll talk a bit about Hyperloop, which is a new product of ours, which helps you to bridge to any API that you have on the target platform, including third-party libraries, any custom Swift Java code that you need directly in JavaScript without depending on us to create an API for it or a module or whatever. So let's start with Appcelerator, and you might have heard that as of this morning, not only we are about more than apps, we are now also part of something more. We've been acquired by Xway. It has been announced this morning. Xway is a lot bigger than we are. We are about 80 people, and Xway is about 2,000. But Xway doesn't do anything that we did, so we've been acquired as a company that will remain pretty much as is, and just for us it means a lot more stability and a lot more resources to do what we want to do. So I'm very positive about it, and as I said, nothing will change for our users, for our products, nothing will change about our vision. And to tell you a bit about our vision, broader than just apps, I want to show you this movie, which does a great job of explaining that.
They're collaborating, the stuff you do every day, even yesterday's news, because they're being replaced by mobile apps. Great for you, not so great for enterprise IT. Because if they want to keep leading the company in innovations and solutions, they need to be making mobile apps for customers, employees, clients, everyone. Which means dealing with tons of devices and operating systems, mobilizing data sources both inside the enterprise and outside it, and giving users the experience they want, because that is why mobile is thriving and web applications are fading. And that's just for one app. On top of that great experience on every mobile platform and device for each app, IT also has to find a way to connect each app to data sources and a way to measure, well, everything. App adoption, team performance, business ROI, which of course has to be in real time, and that means getting analytic tools compromises, burn tons of money and time on bad results, and get blown away by competitors who do it right. What mobile demands is a new way to build apps and connect them with data sources and measure and analyze them all at once. This isn't a big deal. It's the whole deal. It's also a whole new opportunity to restore sanity, to foster innovation, to forge new market opportunities, to make IT nothing less than the heroes of the business. But how can IT do that with all this complexity? How about a unified platform for creating amazing cross-platform apps, mobilizing any data source, delivering actionable real-time analytics? That'd be nice, huh? Yeah, that's what we thought.
So, as the video said, our vision is to go that apps are not something standalone. There's no app out there on the App Store that doesn't use some kind of an API, some kind of third-party integration maybe. Apps should have analytics just as any website should have analytics. If you don't know what crashes occur, if you don't know how users are using your app, you have no way of telling what the next update should have in terms of features, bug fixes. You need to know how it is used in order to improve it. So our vision is that these three components are equally important, and you cannot just focus on apps alone. So that's also what we offer as a company. Tonight, however, we're going to focus on just the part that we need for building apps. But before we go into that, apart from our analytics, we really have two different stacks in our company. And both are JavaScript. And one is aimed purely on building apps. So we have our titanium alloy that allow you, and I'll explain the exact architecture in a minute, to build native apps. And the other stack is pretty much doing the same, but then for the web. So we have our Arrow Builder, which is kind of an MVC on top of JavaScript APIs. And then Arrow Cloud, which is a Node.js host, plus some built-in APIs and services, to do exactly the same, but then for web apps. And then we focus on, you could build any website on top of our stack, and actually all of our own web properties are built on our own Arrow stack. But they're primarily focused on building APIs and on allowing you to do so very quickly. So we have connectors to a whole range of data sources. And my favorite anecdote is that we once came into this Fortune 500 company in the US, and they already spent 3 weeks on trying to create middleware for the SAP backend that they had for their apps. They just needed to extract some data, do some transformation, aggregate it with some other data, and get it to their apps. And they spent 3 weeks on it, and they kind of got it together. So we got in and did our demo on our Arrow stack, and we did exactly the same thing within the hour. So that's kind of the goal that we have, to make it easier to build apps, but also to build the APIs that they need. So enough about Appcelerator and the products that we have. Tonight is all about JavaScript and about JavaScript to build native apps. I always emphasize that it's about native apps because so often when you start talking about JavaScript, people also assume that it also includes HTML. And I always have to tell the story that no, we're not about HTML. There's not a single line of HTML in our apps unless you, for some reason, put it in there. Our interface is purely native. It's no different than if you would code an app in Xcode or Android Studio or Visual Studio. It's a native UI. And to explain a bit on how that is different from the HTML apps that we've seen with Fokke and Cordova, if you look at an app like that, it's basically a web browser. It's a full screen web browser where you hide the toolbar and the location bar, so to say, and you, instead of showing a remote website, we're showing a website that's embedded in the app. Now, what you want to do in an app is you want to access APIs like geolocation, camera, and all other stuff, files, local files, iCloud, push notifications maybe. And in order to do that, you need to access the system APIs. And of course, we have seen a whole lot of HTML5 APIs that you can now use to select a file from your photo gallery or get your geolocation. But for the same reason that you website that you visit on your desktop to be able to reach into your system and talk to any API or go into your file system or whatever. For the same reason, a web app embedded in a tool like Cordova is not able to reach into the platform APIs and just talk to any of them. So what the approach is here, that these apps have embedded a website, but also they embed kind of a, you could think of it like a local web host, or a local host, where they talk to. Mostly this happens, for example, in Cordova on iOS. What it does, it has an iframe, hidden iframe in your embedded website, and it changes the source of the iframe to a custom URL scheme that is then picked up by the local host also embedded in the same app. So you're doing a request to this local host. The local host, since it is programmed as a local host in the native app, is able to reach into any of the device APIs, do the actual request, and then returns a kind of JSON or XML that can then be interpreted again. So this is really, if it sounds like a bottleneck and kind of like a hack to you, that's what it sounds to me as well. And that's also what has been limiting these apps for a long time. Now a good thing for HTML apps is the reason, or like since iOS 8 trend for flat UI. That has made it a lot easier to build HTML apps that actually look pretty good compared to the native counterparts. But still, because it's HTML, you can do anything. I mean, you could do an iOS-looking app like a button tab group. I mean, that's just not something you have on Android. But you can do it because it's HTML. You can do anything. And some see that as a good thing. But before I joined Appcelerator, I worked as a freelance developer, and I didn't particularly like clients that come up to me and say, well, I want this app, and I want them to look the same on iOS and on Android. I usually try to avoid these kinds of clients, right? Because I sincerely don't believe that will get you the best user experience. To get the best user experience, you need to use the actual UI components that the platform offers. You need to use an action bar on Android. You should use a navigation window and a tab group on iOS. And honestly, for that I hate the hamburger menu. It's total useless and crap. On Android, go ahead and use the trial layout, but on iOS, please don't try to imitate it. It's a bad UI paradigm. So the HTML apps, they have their place. There has been a very strong HTML versus native debate in the recent years, and I'm glad that in the last year or so we kind of got beyond it, because there's actually a lot of good reasons why you should HTML apps, especially when you're doing internal apps for companies where you want to get them out quick, where you have an environment that you can guarantee that is secure. There's a lot of reasons, a lot of use cases where you could actually use these HTML apps. But for consumer-facing apps where you want a good user experience, I think native UI is a must. So how does JavaScript to native work? Well, again, you use JavaScript to talk to the APIs. When instead of having having a full-screen web view or web browsing app, the JavaScript runs in a JavaScript engine embedded in the app, in a virtual machine. So you're not executing JavaScript in the web browser, you're executing it in a local VM. So on iOS, we use JavaScript core as it is already available. On Android, we embed a copy of V8, and on Windows, we've ported JavaScript core to Windows. So by running it in the app itself, in a virtual machine, we can do exactly what the JavaScript itself does. We can inject APIs in JavaScript. Whatever you call date or parse int or parse float or whatever, those functions are not coded in JavaScript. They are coded in whatever language the JavaScript engine was written in. And that's exactly what we do. We inject variables in the JavaScript engine, and because they live on both sides, in both worlds, they are JavaScript objects, but they are injected from the target platform language. they can cross that bridge, and they can, without using iframes or any hacks, they live on both sides, so they can talk to both sides. So as you can see here, we have the JavaScript world where all of your code lives, and then we have Titanium, and it works in exactly the same way for React Native or NativeScript or any other JavaScript or native solution. Lives on both sides and can, for the JavaScript, talk to the native APIs. Any questions about this before we go a little bit deeper in specific architecture of Titanium? Yeah, go ahead.
So is it like a JavaScript interpreter, or do you translate the functions to the native?
No, it's an interpreter. Yeah, so we run a virtual machine in the app which executes the JavaScript in real time. Yeah.
What is that different from an IDE?
With a web view, you mean?
No, I mean like they both sound like it sounds like this also sounds like
Well, this is just like a JavaScript course.
Yeah,
It's a feature of the JavaScript engine. It has an API which allows you to inject any object which lives on both sides. So it's not it's a hack, it's an official function of the engine. Okay, so if we look at the thing a little bit closer and see how it works, we can see our LAMVC, which we'll get to in a moment. And what is important to know about the LAMVC is that it lives in your code base. It lives when you're developing the app. But as soon as you build it and package it as an IPA or APK, Alloy is not there anymore. Alloy, we'll come to talk about that in a minute, but it's XML, JSON-like styling language. But all that is not in the app itself. It's all compiled down to JavaScript, transpiled to JavaScript. So the only language that you'll see in the app itself is JavaScript code. The JavaScript code talks to Titanium core APIs, module APIs, and then Hyperloop. These are cross-platform APIs for UI components, for system APIs. And this is something that we write against our own bridge here layer, which is crawl on iOS and Android, and HAL on Windows is our bridging layers that we have developed. And the core APIs, they provide cross-platform functionality. For example, if you create a label, we take care of creating a text widget on button on Android and a UI label on iOS. You don't need to know the differences, we take care of it. So we have this cross-platform APIs. But what we don't do is imitate UI components that don't exist on the platform. So if you have an action bar, you will find it in our APIs for Android. We don't offer a similar component for iOS. You just need to use the iOS specific component or an alternative. But we don't offer this write once, build anywhere, or run anywhere thing. We believe, yes, you can share as much code as you can between platforms. Most of the time with Titanium you get up to like 90%. But for UI, you need to know use the UI, the platform-specific UI components that you want to target. Now, we don't cover all of the APIs. So we also have a module system where you can pretty much do what we do, implement the APIs that you need to access, write these, and the modules are written in the target language. So if you need a module for both iOS and Android, you need to write the module in Objective-C and in Java. And from then on, you can access it in JavaScript. Now, there are about 1,500 modules out there already. So if you need like a PDF viewer or something, which is not in our core APIs, there is a module for it. So you can just drop it in your project and use it. But if you want to extend an API, you need to know Objective-C or Java or whatever you want to extend to. Now, Hyperloop, in case we don't have enough time to talk about that anymore, but Hyperloop pretty much build the modules you assume are there. So you can do a require in your JavaScript code, a require UI kit / whatever namespace there. And by reflecting on your code and on the metadata that we have the iOS APIs and any third-party frameworks, we build the module for you when you compile your app. So So you can just assume it is there and we'll build it for you. So this allows you to access any API, third-party buildings, without needing to go in and write the module yourself. And I'll show you some screenshots of how that looks. So from these APIs, through our crawl and HAL layer, you can access any third-party API or built-in OS or UI API. So let's see how this actually looks. So this is a very simple hello world, which just is a window or a screen with a white background with a label on it, and when you tap on the label, it will say hello world. So as you can see, this is all pretty much standard JavaScript. We use factory methods, so you have TI/UI, create window, you know that you're dealing with UI, you know that you're talking about against the Titanium core APIs, because it's in the TI namespace. And what you will get, the window variable, will be a TI/UI window object. And in the documentation, you can look up the properties it has and call any methods on it. But this method lives on both sides, it lives both in JavaScript and in native land, as we call it. So for this window, there's an actual view in Android and on iOS as well. So any changes you do are mapped to the original object, and the same goes for the label or whatever you do. And then if you add an event listener, we add a delegate, etc. So you're dealing with the JavaScript API, but what is being executed on the other side of the bridge is talking to the platform APIs. Now, we have organized our APIs in this manner. So if you, as I told you, any UI component can be found on the TI/UI. You create one of these objects using create X, and then you know that you're creating a TI/UI X object, which you can look up in the documentation. Now, any iOS or Android specific UI components you would find under the TI/UI iOS namespace. So the moment that you are using these, you are aware that if this app is going to be for Android as well, you need to put in some conditional code here to make sure that this only executes on iOS. So you can test if the platform that the user is running is iOS, and then only in that case run this code. So the same goes for device APIs. They're not on the UI namespace, but directly on the TIs, like TI media, TI geolocation, TI core motion, whatever. And you can extend it there. And again, we have platform namespaces there. Now, both Common.js and Titanium modules, so modules bridging more APIs, can be required as if they were a Common.js module. So we first see if there's a Common.js module with this name. If there's none, then we assume you want a native one of the Titanium modules, and then we will require that. And then, but mostly these will work exactly the same way. Of course, it's up to the author of the module. You can do it anyway, but most of the time you'll see that it has create functions, create UI components, or access any device APIs that it exposes. And if you go into a documentation, you'll see we'll have expose a lot of the APIs, both UI components and device APIs, you can all find them there. Now, the file structure for an app is pretty simple. We actually only have two required files. You have a t.xml, that is like your configuration file, so you set all kinds of different settings, like you can set everything you would normally set in the info.plist for iOS or an Android manifest, you can set it here. And things like the app ID and the version and stuff like that, it's all set and configured in that file. And then in your resources folder, you have an app.js, which is your logic. You could put all of your app in that single file, which I will not do. Normally you would use Common.js modules to organize your app, but you could put it all in there. And then you have images and maybe utility libraries and other stuff that you want. And we're going to skip the demo because I was told to keep it under 30 minutes. Maybe we have some time left. Yeah, we have several solutions for there. We have live view, with you can build your app once and do a quick edit, mostly for tweaking UI, save, and it's immediately reflected on the device or on multiple devices. And then for automated testing, we have an integration with SOSTA, so you can record tests there. But there's also a lot of community projects out there that use, especially for unit testing, YesMine or Mockup, or a lot of different things that you can use to test there. Yeah. And you can also, of course, just drop it in any of these test clouds for Amazon. Since in the end you just get a normal IPA, you can pretty much test it in any way that you would normally test your Xcode or Android Studio with that.
Is there a comment from JS? You said it was an ECMAScript 6 type of support?
I'm not sure what we recently updated the V8 engine because we use a fork. We had to make some changes to V8 to get it working.